So, welcome to my dear um, students and learners. So, hope this will be sixth lecture in this series. So, today we are going to learn about linear regressions. So, this is a very important tool in machine learning as well as sometime in deep learnings also. So, I'll just teach you that syntax with some example because in case of machine learning as well as deep learning also you can take one example like when you are is a face recognitions, you are training a network. Okay, so basically your image, it will be converted into one matrix, and with the help of those matrix taking as input of a particular network, it will be trained. Okay, so everywhere whatever I will be telling you, that will be some point of time it will be required for you. Just it's very simple, just you have to remember the memorize the syntax of it, otherwise you know everything. Just okay, so sorry for the interruption, because one important call came. Anyway, so today we are going to this whatever I was just telling, whatever I am explaining, that will be required some point of time, so you have to follow properly, otherwise at that time it will be difficult to recall all the things together. Okay, so we know all about uh, everyone, we know about the linear regression. So today we will learn how to fit the curve for single variable as well as multiple variables. Okay, sometimes some of the in some relation the input variables are more than one. Okay, depending on so many factors, one output is to be predicted. So in such case you need to know this linear regression for multiple variable. Okay, so we'll be opening. So this already we know everything. So here first we have to import few libraries, because the main thing is the mathematical libraries. We use pandas. So this is the alias name I am giving. Then import cburn as sb. I am just giving a particular alias name. Then from sklearn, already these are the things we learned in the earlier lecture, and here we are going to use linear model. Okay, now the first thing is we have to read the data. So already I have created one table. So this is one table. So here one table I created. So the name is, so what is to be done, so we have to copy the path. So this is the thing, copy. Then I'm defining one data type. This is equal to pd dot read excel. Then we have to give the path, then the file name. This is test dot xlsx. Okay, now you can see the table here. Sorry, you can see. So what I did, basically, this is the input, and here is a linear output, 5, 9, 13, 17, and this is some of the predict, means arbitrarily I put the output, this out one variable, like this, so that we can see the best fitting. Okay, so here we can see the plot, giving the lm plot command. Now your x I can take as, that is the input, and y I can take as out one. Then the data is equal to the value I am taking from the data dt. Okay, now you can see this is the because as the data is not so accurate, so this line, based on the output, this here, this the best fitting, most appropriate fitting is executed. Okay, now suppose from this prediction I want to predict some value which is not in the table, and the data range may be outside of the table, uh, or it will be inside, but it is not in that exactly, the value is not tabulated. Okay, so for that we have to feed the curve. So I am giving the one variable name curve. It's simple, just then linear underscore model, then linear regression. I am using linear regression. Okay, then we have to feed the curve. I'm fitting the curve, then the data type, then I will take the input. Okay, because it's this is a two-dimensional, and then data, then it is that out one. Okay, it is fitted. Now let us check some value, so which is beyond that. So it is, the value is I think this value is up to 18. So we'll see something 20, what is the value, how correct it is. So that command is prediction, already we learned it. Carve dot predict, then you take the value, say 20, then run it. See, it is coming 84. So this is, and if you know this, for a single variable, the curve, um, uh, the linear equation is y is equal to mx plus c, where y is the dependent variable and m is the gradient or slope of the curve, and c is the intercept. So if you want to know the equation also, so simple, you type curve dot coefficient is the command, So sorry. So you see the value of m or the gradient is 3.89, and if you want to know the intercept, curve dot inter intercept, CPT intercept. So this is, so what is the basically the equation? Y is equal to 3.8982x plus 6.3894. This is the equation. So this is a very simple syntax, and hope you understand this. This is a single variable. Say there is a huge data you got, from there you have to fit if the relation, you know about the dynamics of the system, say it is a linear, mostly linear relationship. So in that case, this linear model, in this way you need to fit it. Okay, now I will go to another example. uh, Say I have created one, again one more table arbitrarily. So here you see this is input 1, input 2, input 3, input 4, and there is output. Okay, in such case, how you will fit it? Okay, how you will fit it? Because the output is dependent on four variables in that case. So it's also very simple. So let us again import pandas as PD, then import Seaborn as SB. So these are the because I am not going inside about this library. You can simply, because Python is a very popular language nowadays. If you type what is that, because it will, because time is very short. So if I want to discuss all these things individually, then it will take much more time. You can simple type C1, so you will get all the things. What about this? What, basically it's a library. Okay, in C there is a inbuilt library. So if you want to do anything, you have to call that. So it is like that only. Okay. So again, I have to read that file, read that Excel file. So the command is pd dot, sorry, pd dot read Excel. Then you have to give the path of that. So again, I have to type the path of this. So this is the path. Okay. So you can give the path. Then the file name is test1 dot xlsx. Okay. Let us see. Yes. So this is the table. So in case of linear regression for multiple variables, so this is y is equal to m1 x1 plus m2 x2 plus m3 x3 dot plus c, that intercept. Okay, this is basically we are going to fit it. So simply again I can give the variable name as curve, and it's a we have to import the linear model also. So sklearn from sklearn we have to import linear model, because we are considering everything as linear. So now, so now I will read the already the data has been now I will try to fit it. Okay, so I am giving the variable name curve, and linear model dot linear regression. Okay, then I need to fit it, curve dot fit. Now that will be the first we have to define the give the data name, and it's a like two dimensional as I told. So this is in 1 comma in 2 in 4 in sorry, in 1 in 2 in 3 comma in 4. Okay, then the output is my out, the variable name is out. So this is out, sorry, out. Then the data is equal to dt. Am I right? So let us run it. What is it? Okay, already this I have defined. So the now the model is fit. Okay, so now you need to predict the value. So again, the command is curve dot fit. Now I'll give a value. Let us give a value from the table itself. Let us give this 2331. 2331, the value should come 12. So 2331. Sorry. Sorry. This will be oof. This will be not fit, it will be predict. PRED. So the value is 13.29. Okay. So, but you see here the value is around coming 12. So those are the valid features now. Okay, no problem. One warning is coming. It is nothing. So this is the thing. So in this way you can feed the so now here also you can you can find out the equation also. So you need to know the coefficient, and you need to know the constant. So this is so now from there you can understand the equation is equal to y is equal to 2.99 x1 minus 5.17 x2 plus 5.98 x3 minus 4.22 x4 plus 9.11. This is the equation. So these are the very fundamental, and the same thing I will why I am using, as I told, the final project. Say it may be some face recognition or some image recognition, some annual recognition or something. This we are going to learn in MATLAB, because otherwise everything you have to write these things from the scratch. In MATLAB, all these things made much more user friendly to work with the real life problem. So tomorrow, the in the next class, we will learn the same thing, how to do it in MATLAB. Okay. So the assignment of today's class, and one thing I am telling, the certificate will be issued on behalf of Institute of Engineers. So they will ask some documentary evidence of your participation and all these things. So for that only I am asking, please you submit the assignment regularly, okay, so that I can issue the certificate. Otherwise, if you simply not submitting anything timely, then I have to write the only as you participated. I cannot write you that the course you completed the course. I will write, instead of completion, I will write participation. Okay. So please regularly you follow the things, and try to submit the assignment regularly. Okay. At the end of the course, hope you will get some idea, and you can, who are really dealing with artificial intelligence, machine and deep learning, they will be benefited surely. I am going very slowly so that you can capture it, and you can follow me. Thank you so much. Thanks for your patience.